Hello everyone, welcome to Look, Learn and Lead. Today we'll be talking about the basics of system design. System design is not that complicated if we know how to approach the use case. So the first thing that we are going to do is get the use case or the problem statement right. See if the problem can be split into sub-problems and then whether those sub-problems can be handled individually or not. Then we will focus on the requirement gathering. It's a very crucial step because the requirement gathering will identify the scope of the design. Scope here is a generic term. However, we can quantify it in terms of number of users or data. Then we have factors like scalability, and then there are other factors like latency, high availability, and many other things. So when we have the scope figured out, we can do a deep dive analysis into each of these factors. Suppose, what will we do if the number of users are more than 1 million? How to handle that? What will we do if we have terabytes of data or more than that? Do we really need to scale the design or not in future, or how to make it scalable? So once this analysis has been done, then we can jump into the design part of it. I would suggest to get an overview of the latest technologies. Those technologies will help us getting a better design, and then jump into the implementation part of it. There is a possibility that when we are implementing the design, we realize that we have missed out on some of the cases or scenarios. So we go back to the design, or we can simply go back, rescope the requirement, do a further analysis, and then redesign. So this is kind of a continuous process if you see here to get the perfect design which matches the requirement. Here I have two kinds of architecture, monolithic and microservices. Understanding these architecture will help us understand why the requirement gathering, scoping and analysis is very important in the system design. Not every use case has to be handled in a distributed or a microservice way just because it's in demand. There are few smaller use cases which does not require scaling or too much of tapping into changes that does not require scaling. So we can always go for an architecture like this one where everything is a single unit with a single data center or centralized data center. Microservices, on the other hand, if you see, each microservice is an independent unit with its own logic and its own DB. Now, let's focus on the pros and cons of the monolithic and microservice architecture. All the monolithic architecture is a one system, or they are all connected and interdependent. Microservices, we break down each problem or subproblem into smaller units which has its own logic and database, and the microservices kind of communicate through APIs. So having a unified unit has its own advantages. So there will be less cross-cutting concerns like logging, error handling, caching, performance, monitoring. Everything will be at one place. So it will be easy to deploy and easy to debug and test. Similarly, microservices has its own advantages. Since we are having smaller independent units, it will be easy to understand, easy to scale. So if you want to add some additional features, you can always add a separate microservice. Similarly, flexibility in choosing the new technologies to integrate it will be easier because we are handling things at the microservice level and not the entire code base. Higher level of agility. So since all the microservices are independent units, if one of them fails, the entire system is not affected. Here we will see the cons. It's a one system, so not easy to scale. There is no modularity, so it will be hard to manage and difficult to understand. And With the new tech barriers, it will be difficult to integrate. I won't say it's impossible, but it will be really, really difficult to integrate new technologies to the existing system. Here, the cons will be like, suppose microservices are smaller independent units. So how do we know what microservice is running where? How do we connect? So we have to hold that information somewhere. So we need an external config. Again, logging, metric, health check, all these has to be done at individual microservice level. So tracking them will be difficult. End-to-end testing will also be harder that way. And also, in addition to that, deployment will be more complex as we have to have the information between the DB, the microservices, and make sure that we have the right connection information. Something goes wrong, the entire system is down. So monolithics are useful for smaller projects, of course, which requires less or no scalability at all. Microservices will be for complex and scalable applications. Mostly these days we call them as distributed systems. I would like to shed some light on the service-oriented architecture here. Monolithic, we have discussed the pros and cons and everything and stuff, but service-oriented architecture, if you see the diagram here, the services are exposed and we have an enterprise service bus through which we can interact with the service. Here, if you see, we have a reusability aspect to the code. Like I said, business logic reusability, but microservices is mostly decoupled independent units. Communication will be through enterprise service bus. It's a predefined standard protocol, and data store is a single data store which is shared. Here, communication will be like messages system which are lightweight protocols. HTTP, REST APIs we'll use, and each microservice has its own DB. I will be discussing some real-time use cases and show you how requirement gathering and scope analysis is really important to identify what kind of system we need to design. Example 1 here is online cab booking like Ola, Uber, Lyft, Grab, etc. So from the requirement gathering perspective, I have added few points here. So the passenger should be able to, see all the cabs around. He should be able to book. Then he should be able to view the path to his destination, his own location, driver's location, etc. Similarly, the driver should be able to get a request, accept it. Then again, there are other things like his own location, passenger's location, then the path to the passenger or the destination, and other factors. Then we have a map service also. So the map service will be responsible for location and path information, right? So these are kind of requirements. But other than that, when we try to scope it, like how many number of users are we expecting? It could be more than millions, 10 lakh, 20 lakh. Then what kind of data? Lot of data, and especially real-time data we'll be expecting. Then do we need to scale? Yes, we need to scale because the users will keep on increasing once the application becomes a hit. So if you see this, a monolithic kind of architecture is not going to work for us, right? We should go with the distributed system. Example 2, parking lot. So I specifically took this example to give an idea that not all use cases have to be a distributed or a microservice based architecture. Here we'll consider some of the use cases like book a parking lot at entrance. When you are exiting, you should be able to pay the charges. So what kind of charges we have, hourly charges and all. Then what should be the capacity. Then there should be some monitoring and few other things we can add to the list of the requirement, right? But again, if we try to scope it, how many users can we have? It's a parking lot, right? Maybe like 10k to 20k. How much data will generate? I don't think it will go till terabytes or something. It will be less than terabytes. Do we really need to scale? We can customize the application to scale a little bit in terms of, say, levels in the parking lot, capacity, how many entrances we want, right? These kind of things we'll focus on. So if you see here, we'll need microservices, right? So it could be a simple monolithic one, not distributed. We can go with a monolithic approach here. Third example is a classic real-time example, a messaging system like WhatsApp, Signal, Facebook. So we have a requirement gathering here. User should be able to send and receive messages, do a group chat, send images and files, get notification if they are offline. And here number of users, if we try to scope it, it will be huge, more than 1 million or so, right? Then the data generated in terms of chats, files, group chat, it will be very large. It could be in terabytes. Yes, we would want to scale this in future. Then there will be other factors like responsiveness. Minimum latency should be there when you are sending the messages. Other factors like high availability. Whenever you open your chat window, you should always be able to see the messages all the time. So these kind of factors comes into picture. Of course, here monolithic will not work. We should go for a distributed based approach or a microservice based architecture. So far, we haven't come across any software oriented architecture design. Again, it completely depends upon how you want to approach. One example I can give is, suppose in mobile applications we have a GPS system, right? So any application would want to access the location of the user. So this GPS can expose an API to get the location. So this can be used as a service by other applications to get the location of the user. So it's a very generic SOA example. So today we discussed the basics of system design, why it is important to get the requirement right, to get the scope right, and then you jump into the analysis and design part of it. In the future videos, I'll be discussing more about designing real-time application. If you found the video useful, please like, share, and subscribe.